Hello everyone, once again you're welcome to this channel. Today we have a peculiar question from damp natural frequency of a spherical ball submerged into the water. Now let's read to the following question. A spherical ball of radius 0.4 meters floats half submerged in the water with a density of 1000 kilogram meter cube. The ball is depressed slightly and then released. Assuming the ball is attached to a damper with a damping constant C, which equals 300 Newton seconds per meter. The damp natural frequency is. Now we are here to calculate the damp natural frequency of the submerged ball, assuming that the density of the ball, rho b, and the mass of the ball, mb, equals rho bv, that is the volume of the sphere, equals rho b, that is the density of the ball, multiplied by 4 over 3 pi r raised to power 3. Note that the buoyancy force equals the product of the density to the volume of the immersed object multiplied by the gravity. And our gravity g, acceleration due to gravity, equals 9.81 meter per second, which is gravitational acceleration. Now, using the schematic given below, we can deduce that our static equation from the point of reference here is telling us that the mass of the ball has the vertical forces pointing upward, which is half of rho w, that is the mass, half of the density of the water multiplied by 4 over 3 pi r3g, whereby the downward force mbg equals rho b 4 over 3 pi r raised to power 3g. Now, by equating both equations, that is the downward and the upward, we have this particular equation that gives us half rho w 4 over 3 pi r3g equals rho b 4 over 3 pi r3g. That gives us rho b equals half of rho w. So therefore, from there we can deduce that the density of water is half of the ball. So from there we can deduce also the dynamic point of reference to get the equation. From here we know that when the ball is immersed into the water, the damping force Cx, which is the velocity, will be acting on it too. So that gives us rho w multiplied by pi r square x into g, with the velocity of the damping force, which gives us this particular equation to be m dot dot plus cs dot plus w rho w into bracket pi r square x multiplied by g. That gives us m s dot dot plus cx plus rho w pi r square gx. Now, by linearizing this particular equation with the standardized second order equation for a dynamic response, which is given in our standard sheet, we can deduce that our k, which is the k constant, becomes rho w pi r square g. Now we can input all our data. First of all, let's pull out all the parameters. To pull out all the parameters, we have our r, which equals 0.4, the density of the water 1000, the c constant 300 Newton seconds per meter. So we can slot in to find the density of the ball, which is half of the density of the water. That gives us 500 kilogram per meter cube. From there, we can slot in the value to find our MB. Our MB, which equals 4 over 3 multiplied by the density of the ball multiplied by pi to the radius. That gives us MB equals 133.97 kilogram. That is the mass of the ball. Now that we have found the mass of the ball immersed in the water or depressed slightly in the water, now we can find the damping ratio, which is C, by using the formula C over 2 in square root of rho W pi r squared GM. That gives us this particular value by slotting it to the equation. We have 300 over 2 into bracket 1000 multiplied by 3.14 multiplied by 0.4 raised to power 2 times 9.81 multiplied by 19.97. Our calculated damping ratio gives us 0.19. And also we can calculate the Wn, that is the natural frequency, Wn, which is K over M. Don't let us forget our K equals rho W pi r squared Gx. So by slotting all the values into this particular equation, we have our natural frequency to be 6.07 radian per second. Now by slotting all our value, which is the damping ratio and the natural frequency, into this particular equation, we can deduce and find our damp natural frequency, which is what we have to find. So our WD, that is the damp natural frequency, equals Wn into bracket 1 minus the damping ratio squared. That gives us WD equals 6.07 multiplied by 1 minus 0.19 squared, all into square root. That gives us WD equals 5.96 radian per second, which is our damp natural frequency of the spherical ball submerged in the water. Thank you.